In the previous video, I showed how to calculate some average rates of change purely geometrically, giving this function blue and red that we don't even have the equations for, we just have the graphs for. In this video, I kind of want to do the converse where we calculate average rates of change, but now purely algebraically. We don't have any graphs at all, we just have the equations of the functions. Let's start with g of x equals the square root of x minus 5. Note that we're given two different x values. Maybe I'll call the first one x1 and the second one x2. The average rate of change of the function g is just the difference in the two outputs, which I can denote as g of x2 minus g of x1, divided by the difference in the two inputs, x2 minus x1. I need four values to put into this formula. Two of them are given to me in the problem. All I got to figure out is what is g of x1 and what is g of x2. And those are both doable because I know x1 and x2. x1 is 6, so g of x1 is just asking me what is g of 6. In other words, what will come out of this machine if I put 6 into it. I can figure out what comes out of this machine when I put 6 into it because I have the blueprint for the machine right here. This tells me what comes out of the machine when I put any value x into it. So to figure out what comes out when I put 6 in, I just copy exactly what I see here, except I change all the x's into 6's. So I get the square root of 6 minus 5. 6 minus 5 is 1, so I get the square root of 1, which is just equal to 1. What I'm saying is when you put 6 into this machine, 1 comes out. Similarly, when I put x2 into this machine, since x2 is 14, I'm just evaluating g of 14. G of 14 would just be the square root of, changing this x into a 14, 14 minus 5. 14 minus 5 is 9, and the square root of 9 is 3. So when I put 14 into the machine, 3 comes out. I now have the four values that I need, x1, x2, g of x1, and g of x2, to calculate my average rate of change. G of x2 is 3, g of x1 is 1, and then I want to divide that by x2 is 14, and x1 is 6. 3 minus 1 is 2, 14 minus 6 is 8, 2 divided by 8 is a quarter. The average rate of change of this function g from x equals 6 to x equals 14 is just a quarter. That's it. Really all we're doing on every one of these examples is we're just reusing this formula right here, which has four different values. Two of those values are always given to you in the problem, and the other two you can calculate pretty directly because the equation of the function is given to you in each of these problems. Let's do one more, then we'll call this good. The average rate of change of this function h, which is given by this equation, from maybe x1 is equal to 1 to x2, which is equal to 11. Well, my average rate of change formula, since the name of my function is h, would be h of x2 minus h of x1 divided by x2 minus x1. Again, it's just the difference in the outputs divided by the difference in the inputs. The two inputs are given to me, so I just need to figure out what are the two corresponding outputs. What is h of x1 and what is h of x2? x1 is given to me to be the number 1, so I just need to know what's h of 1. To figure out h of 1, all I'm going to do is copy exactly what I see here, except change all the x's into 1s, the input into this machine. So I have 2 divided by 1 minus 3. Let's see, 1 minus 3 is negative 2, so I have 2 divided by negative 2, in other words, negative 1. When I put 1 into the machine, negative 1 comes out. What about when I put 11, x2, into the machine? Well, h of 11, I would figure out by just copying what I see here, but changing all the x's into 11s. So it's 2 divided by 11 minus 3. 11 minus 3 is 8, so I have 2 divided by 8, in other words, 1 quarter. I now have the four values that I need to put into my average rate of change formula, the two x coordinates and the corresponding h of x coordinates. So now it's just plugging in numbers. H of x2, which is 1/4, minus h of x1, which is negative 1, divided by x2, which is 11, minus x1, which is 1. 1/4 minus negative 1 is the same as 1/4 plus 1. And if you think about that plus 1 as plus 4/4, you can get that the numerator is 5/4 and the denominator is 11 minus 1, or 10. When we're dividing fractions by numbers, it helps to make it a fraction divided by a fraction. So I'll change that 10 into 10 over 1. And then the way I divide fractions is I multiply by the reciprocal of the denominator. In other words, change this division into multiplication by changing this 10 over 1 into 1 over 10. So I got 5/4 times 1/10. You can multiply straight across and get 5/40 if you want, or you could cancel this 5 and this 10 to make it a 1 up top and a 2 down here, and 4 times 2 gives me 8. This big mess simplifies all the way down to 1/8, which would be the average rate of change of this function h from x1 equals 1 to x2 equals 11. One little note I want to add that you really don't have to worry about at all is this is kind of a bad example, because when we talk about average rate of change, really we want what's called a continuous function, and this function has a discontinuity at x equals 3, which falls in between these two values. So really I shouldn't be calculating the average rate of change with this example, but since we haven't learned about discontinuities, and I'm guessing most people watching this wouldn't even notice that, you can ignore all that. Sure, technically it's a bad example, but for what I'm trying to illustrate, it works out just fine. What I want you to take from this is that when you're trying to figure out the average rate of change and you're given these two different numeric x values, all you need to do is figure out the corresponding outputs and then plug them into this formula. And that's true whether we're doing things algebraically or geometrically. The only difference is how you get the corresponding outputs. If our function is given to us algebraically, we calculate the outputs like I did in this video by copying the blueprint and changing all the x's into whatever the input is. And if our function is given to us geometrically, then we calculate the outputs by locating the height on the graph of the corresponding inputs. That's all. In this last example, the simplification got a little bit complicated because I had to add and subtract and divide fractions by whole numbers, but don't let the arithmetic down here throw you off. The new concepts in this section are average rate of change, and average rate of change is just using this formula, and to use the formula, you need to figure out the outputs. That's it.